Right now, what Pete is doing, Pete Schultz is firing a projectile into an ice sheet that he's made and put into the target chamber. And you can see the breakup, the ejecta of this ice sheet by a single impactor. All this happens within a very short period of time. This is slow motion, 60,000 frames per second. Pete will be opening up its chamber door, which is very big. The chamber is 9 cubic meters, and it's a very large chamber. Now, this is the red dirt underneath that the ice was laid on, and you can see some of the action of the breakup of the ice and some sort of weird morphology that is underneath. The point here is that you can break up this ice and eject ice out rapidly. This was courtesy of National Geographic, by the way. In the audience is Carolyn Shoemaker, and this is the famous comet Shoemaker-Levy 9 that impacted into Jupiter in the mid-90s. And Caroline and her husband and Levy discovered this stream of comets. Apparently the mother comet came around and was disrupted by tidal forces by Jupiter and another pass, yet it was a linear effect. They one by one kept plopping into Jupiter as Jupiter was rotating. And I believe, Carol, if I'm not mistaken, I think the size of the mother comet before it broke up was about 4 to 5 kilometers. Is that about right? And I think there was something like 21 of these. The largest was maybe a little over a kilometer in diameter, and they kept peppering into Jupiter and made huge explosions in the Jovian atmosphere. However, we're not postulating that. We'd like to see something that is sort of a cluster of comet fragments that have broken up in space by other forces, other perturbations, or this is the comet Levy, linear. These are dozens and dozens of large pieces of a comet. This would illustrate that these things do happen. And quite possibly, like comet Schwarzmann-Walkman, they're very large pieces, and this is several less. Sorry. Come back. This is very long, several thousand kilometers, and the width of this thing is about a third of the width of the United States from north to south. So these things can be very large, hundreds of very large objects moving at 40 to 60 kilometers per second. That's about 100 times faster than a rifle bullet. So there's a lot of kinetic energy involved in each of these little pieces, and acting as a group can be devastating. So we have a little artist concept here, a scenario where we're getting one of these comet clusters coming into the Earth and will impact as a cluster mass in North America, preferably mostly over the ice sheet. We have a little movie here. This is not quite accurate as a comet breaks up, but you get the idea that when anything breaks up and strikes the ground, it's much like cluster bombs that were used in Vietnam. They're very devastating, and they can tear up a lot of area rapidly without leaving much of a crater. So, summary. Somewhere. You know that the event occurred 12.9 thousand years ago, and it's a very narrow age range. Not too much happened after that, right at that time, 100 years by radiocarbon dating. We think there were thousands of airbursts over the northern hemisphere. The YDB layer is found on 2 continents. That's a good line of evidence. Many thousands of kilometers of Laurentide meltwater was instantly released into the North Atlantic and other areas. The halt of the North Atlantic circulation engine, as Alan pointed out, initiated younger Dryas cooling, triggered major adaptation by the Clovis, didn't maybe wipe them out, but forced them to go to a better country. Impact changed the climate and probably caused the megafauna extinction. Now, we think we have good lines of evidence for this happening. We think it happened by impact. We think it happened from an aerial burst that did touch the ground. The best line of evidence we have are the diamonds. And the Lonsdale, the hexagonal diamond, can only be made by shock. Cubic can be made by shock. They can also be made in the earth and when the earth those other fingers. So in closing here, I can say that diamonds are a scientist's best friend. What's all of you are tired of hearing about him now?
Within weeks of days, certainly not where I want to go. So, follow up. Is there a missing record in Greenland and other ice sheets that would tell that 10 years worth of surface ice snow is melted off?
Well, as far as the atmosphere being hot, it's only going to be hot for a short period of time. But the surface effects will melt the ice and maybe heat up the water. These are short periods of time. It's the destabilization of the ice sheet which caused the damage.
I think it melted the ice sheet.
Yeah, probably didn't get that hot, no indication that it did. I don't think there are any missing layers in the ice sheet when they do the gas analysis. You know, maybe it was that stuff, but no evidence for it. So we don't think it was that hot. Unlike the KT, which really barbecued lots of things, you know, this one could have killed things by the blast, but quite likely the climate change is what did things in, because it was quite likely very rapid. So.
You want to hear our question, too?
Why were all the megafauna killed but not the people?
Well, it's mainly the food chain. You kill it. In the KT event, any animal that weighed more than 25 kilos, surface, land, water, went to extinction. At the YDB, any animal that was bigger than 50 kilos was wiped out. They couldn't adapt as quickly to the destruction of the food chain as humans could by migration. Or they got wiped out. We don't know what happened to Clovis. But there were other cultures that did survive, and they moved on. You see, the YD event did set fire to a lot of areas, but not like what happened at the KT event. But it was enough to, the large animals didn't have the smaller ones, that is, those that